Welcome back, guys. In this video, I'm going to talk about the dot product and collinear vectors and how they relate. And to explain that further, I'm going to do two examples, so parts A and B. We got vectors A and B in each, and we're going to find the angles between the two vectors in each scenario. So whenever you're given a question like this, where you're given two vectors in component form, you got to find the angle in between them. What are you going to use? Well, usually you're going to use that dot product formula. So we got A dot B is the magnitude of A times the magnitude of B times cos theta. And we're going to be solving for that theta. So starting off with part A, notice we could find the dot product. So A dot B would be -1 times -3, which is +3, plus 6 times 2, 12, so 3 plus 12 is 15. Then -3 times 9 is 27. So 15 plus 27, that gives us 42. So that is the dot product of these two vectors. Then the magnitude of A, so let's do that down here. It's going to be the square root of what? All of the components squared and added together. So we'd have 1 plus 4 plus 9, which would give us 14. So we know the magnitude of A is the square root of 14. So this is the square root of 14. Then the magnitude of B would be what? It would be the square root of -3 squared plus 6 squared plus -9 squared. And when you do that in your calculator, you would end up getting root 126. So the magnitude of B is root 126. And then we're solving for theta. So what we do, we divide both sides by root 14 times root 126 to get that cos theta by itself. So 42 divided by the square root of 14 times the square root of 126. So cos theta, if you do this in your calculator, you actually end up getting 1. So when does cos theta equal 1? If you inverse cos of 1, you would end up getting theta equaling 0. And that makes sense if you remember the cos graph basically starts up here. And when does cos, this is the cos theta graph, when does cos equal 1? Well, at a theta value of 0, or a theta value of 360, but we usually take the smaller degree. So the angle between these two vectors is 0. And that also makes sense because if you look at the vectors, they are collinear. Notice that if we take all of the components of A, multiply it by 3, we would get the components of B. And because we are multiplying it by a positive scalar, it means both of these vectors are going in the same direction. So B would look like this, and then A would look like this. It would be like right on top of it, just 1/3 in size. So notice the vectors are tail to tail. What's the angle in between them? 0 degrees, right? They're right on top of each other, or 360 degrees. But you usually take the smaller angle. So whenever you have collinear vectors, and the scalar between them is positive, it means both of them are going in the same direction, and it means that the angle in between them is 0 degrees. And now let's go through the same process for part B. So let's first find out what A dot B is. I'm going to write it out this time. So it's -4 times 2, so the x components multiplied by each other, plus 2 times -1, the y components multiplied by each other, plus 6 times -3. So this would be -8 minus 2 minus 18, -28. So we know the dot product between these two vectors here is negative 28. What about the magnitude of A? Well, what we would do is we would take the square root of the sum of the components squared. So negative 4 squared plus 2 squared plus 6 squared, and that would give us, 16 plus 4, 20 plus 36, so square root of 56, like that. So the magnitude of A is the square root of 56. And then let's do the magnitude of B. Square root of 2 squared plus negative 1 squared plus negative 3 squared. So we'd have 9 plus 1, 10, plus 4, square root of 14. So this would be the root of 14 here. Then we'd have the cos theta. And now we could isolate for that cos theta. So cos theta would be negative 28 over square root of 56 times the square root of 14. If you plug all of this in your calculator, you would end up getting negative 1 on the left side. And then when you inverse cos negative 1, you'd end up getting theta equaling 180 degrees. So notice how the angle in this question in part B is different than 0 degrees. And notice how both of these vectors are collinear as well. So why is it different? Well, they're collinear, but notice that the scalar in between them is negative. So what we're doing is we're multiplying vector B by negative 2 to get to vector A. Or we're multiplying vector A by negative 1/2 to get to vector B. But either way, it's a negative scalar. So what does that mean? It means that both of these vectors, even though they're along the same line, they're going in the opposite direction. So this is like vector B, and this is like vector A. Right? They're collinear, they're along the same line, but they're going in the opposite direction. So if you attach them tail to tail like we did here, what's the angle in between them? 180 degrees. Right? And that's the point I wanted to make with this video, is that collinear vectors, you can get an angle in between them of either 180 degrees or 0 degrees. If they are related by a scalar that is negative, then the angle in between them is going to be 180 degrees because they're going in the opposite, exact opposite direction. If the scalar in between them is positive, like in this case positive 3, then they're both going to be going in the same direction. And so if you attach them tail to tail, you'll have the smaller vector and then the larger vector, they'll be right on top of each other. And so there's no angle in between them. It's 0 degrees like we got in part A. But the angle in part B was 180 degrees. And again, that's because the collinear vectors were going in the exact opposite direction.